From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you will know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an off-site QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But, as we've talked about on the show multiple times, that's not always as easy as we want it to be. Because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. Love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
Today we're going to talk about Lambda Expressions in Kotlin. Now this is going to be a multi-part series on Lambda Expressions in Kotlin. And you might be wondering why that is, because we haven't really done any multi-part series on any other thing in regards to our Learning Kotlin series. Plain and simple, the reason is Lambdas are kind of a dense topic. There's a lot to explain. If you haven't really worked with them before, it can be pretty confusing. And again, this is audio. I've talked about this before on the podcast that sometimes some of the things we're going to explain here are going to be code, and you're going to visualize this code in your head. And if you've never seen this code before, it can be very confusing. So if I were to talk for 20, 30, 40 minutes on all things Lambda by myself into a microphone as I'm doing now, you might get pretty bored and turn it off, perhaps even fall asleep. So that's not the goal here. The goal is to give you something that you can kind of, interest your mind a little bit so you can go do a little bit of research. I'll provide some snippets of code inside of the show notes so you can check them out. And then as we progress through this short little mini series here on Lambdas in Kotlin, you can continually learn more about how they work. So today we're just going to talk about what they are, kind of some basics and defining those Lambdas in general. So let's get right to it. So first things first, I want to say that I do really enjoy how the JetBrains team has set up the documentation for Kotlin. Unfortunately, I find some of the things kind of confusing as they're very terse and there's a lot of information shortly packed in there and it's very hard to understand it sometimes. So hopefully between this podcast, the documentation and other blog posts, you'll be able to wrap your head around Lambda expressions. So first things first, what really is a Lambda? Now, if you think about it at a high level, and once you understand it, you'll see that Lambda expressions are basically kind of like anonymous functions that we can treat as values. Now, what that means is we can actually take those functions and pass them around as arguments to methods. We can return them from other methods, or we can do things with them that we might be able to do with other normal objects as well. So just the fact that we're able to pass something that looks like a function as an argument in a method, kind of function passing, opens up a whole different realm of possibilities for you. And this is very possible in other languages too. Now, what does a lambda look like? And this is, again, where we're going to get into some code here. Now, as we'll see, lambdas in Kotlin, they do share some similarities to Java lambdas, but I'm not going to get into Java lambdas as this is a Kotlin episode here. But you can definitely look that up on Google. If we want to define a lambda in Kotlin, it's actually pretty easy. So I'm going to do the best I can to explain this here. So assume that you're in your editor and you're going to create a lambda. And it's going to be one line of code here. And we're going to create a val. So this is going to be, a variable of some type, val. And then now we provide the name of our lambda. And this, I'm just going to call it my lambda. This could be whatever you want to call it. Then we need to be able to provide a type for it. So I'd perhaps do colon and then whatever my type is going to be, and then equals. And so I'm going to bring out val, my lambda, colon, the type of my lambda, equals, and then I'm going to do curly braces. And this is all one line. And then it's going to be the argument list, which can be one to many or none. And then an arrow, which is going to be basically kind of like the minus sign in the right arrow, followed by another space, and then the body of code where you're going to do it. So it's kind of, if you look inside the show notes here and swipe over in your player, you should see a little chunk of code that I have pasted in there. You can kind of understand the lambda name, the type, the argument list, and the code body. And if you're driving, don't do that. Pull over if you do that. We don't need any accidents. Okay. So now the only part of the lambda, which basically a lot of these things are optional, and there's reasons for that. But one of the only part that's not optional is the code body, and that's where the code for the lambda is going to be. So you can basically Kotlin through its type inference can basically figure out most of the time what type it is. If we don't need arguments, we don't have to pass those in as well, and so forth. So again, we can skip the argument list if we don't need it. At most the time, the type can often be left out because it's inferred through the Kotlin compiler. And often we don't need variables as well because the lambda can be passed directly as a method argument. So there's a bunch of different stuff that we can do in here. And then of course, the last of it is going to be the returned type here. So let's talk about the type inference for a second. Now, remember we said val, my lambda, and then I specified the type. Well, Kotlin has type inference and the compiler is very good at it. So a lot of times, let's take this a little bit further and perhaps rename this, create a different expression here that you can also look at in the notes. And that's going to be, let's call this one double. And so that's not the type double, but we're going to call the actual variable name double. So val double equals open curly bracket, and then we're going to provide a number. And remember, this is going to be an argument. And so the number is going to number colon, I have to specify the type of that. It's going to be an integer, which means there is one parameter to this lambda function, and it's a number. And then I do the little right-hand arrow. So I do minus sign, right arrow. And then at that point, I do number times 2. And basically that's the code body. So number times 2 is the code body. And at that point in time, the Kotlin compiler is going to look at this and say, hey, okay, I have a lambda expression here. It's called double. It's going to take in a number. And then what it does is it just multiplies that number times 2. And the result of that is just automatically returned as the lambda. And so I can get the value of that saying val result equals double, and then open parentheses, pass in the number 4. So val result equals double, pass in the number 4 as a parameter, close parenthesis, and the value of the result variable at that point in time would be 8. And so what Kotlin does behind the scenes is it evaluates that lambda expression, and it sees that it takes in an integer and it returns an integer. And so we don't have to specify it because of the built-in type inference. Now we could even take this a step further and we could rename that to double string. And what that would do is we just keep the rest of this the same, except this time we could break this lambda expression into a multi-line lambda expression. So we could use the right arrow at the top, and then after that, put a new line. And so we'll kind of think of our open and close curly braces just as we would normally inside of a function or whatever. And the top part shows the actual arguments. And then inside of that is the code body. And inside of there, I might say val result, or say val double value, which is our double result. Val double result equals the number times 2, which again, we know is going to be, if we pass in 4, is going to be 8. And then what I can do is on the next line, I can say, double result dot toString. And what this would do, due to the type inference, is the Kotlin compiler would look at this and say, okay, cool. I'm going to take in an integer for this lambda expression. And whatever that integer is, I know we're going to multiply it times 2. And then you're going to return me back the string value because you called the toString function. And so Kotlin understands that this lambda is of a type integer argument, and it returns a string. Now, there are times also when we want to take an additional argument. So what does that really look like? Well, for example, if we wanted to do that, we could say, define a lambda. So we just call it my lambda again, colon. And this time we could do a open parenthesis, and it's going to take in a string, and then it's going to take in an integer. And then what we'll return is a string. So we say open parenthesis, string, comma, int, close parenthesis, right arrow, the word string. And what this is saying is, hey, Kotlin, we're specifying the exact type declaration right up front here for it. And this is needed sometimes because for whatever reason, Kotlin can't figure out the type declaration. And that just happens sometimes. And if you run into that situation, you'll need to specify the types. And that's what we're doing here is we'll say val my lambda colon, and then we specify the argument list. So string, comma, int, basically saying, hey, this lambda takes a string and an integer. And then the right-hand arrow says, hey, Kotlin, this is going to return a string, okay? And then at that point, we need to be able to provide the actual code body. So we say equals, open curly bracket, and then we have to specify the names of our variables. So we could actually just do it str for string, and then comma int for integer. And those are the variables we'll be able to use inside of our code body for our Lambda expression. We'll do another right arrow saying, okay, here's the implementation of the actual Lambda expression. And here we could just say, we could have it just have a string interpolation. So we'll put some quote marks there, double quotes, and then we'll put the string, of course, with our $sign there. And then we'll put maybe, hyphen to say whatever. We're going to hyphenate it. We're basically going to return the string and the integer in a string value. And then we'll do the int, and we'll say int.toString and use the Lambda expression, the string interpolation method there. And what this simple little method really does is if I pass in the word Donn and the number 32, it would just print out Donn-32 as a string. And that's all this thing would really do. But what this shows is we're actually specifying the exact types of the argument list. We're specifying the return types, the return type of the actual Lambda expression, and then we provide the code body with the actual method names. Now, of course, this is a lot of code, a ton of stuff to digest, really hard to explain over an Audible format. So if you're interested, please swipe over on or scroll up, depends on your podcast tool that you're using, podcast app. Take a look at the show notes that are included with this podcast, and you'll see the example of the code that I'm talking about. And that's going to kind of wrap it up today. Now, if we want to actually, right before we wrap it up, how do we call that? It's just like a function. So if we have it and it's called my lambda, I can just say, hey, val result equals my lambda, and I pass in a string value Donn, comma, 32, close parentheses. I treat it like a function. And then at that point in time, that code will be run. Now, the cool thing about that lambda expression is I can actually start using that lambda expression as a parameter. So if I have a function, I can create a function, and one of the function's parameter would take in a lambda of type string, an integer, and return a string. And that would actually be the Lambda expression that it could take in as a function parameter. So I could do a whole bunch of other stuff in my function, and then I could invoke that function. And we'll get to that in the next episode here on Fragmented, where we talk about how you can actually call a Lambda expression from within another function and all the kind of stuff around that. So again, to kind of recap, it's pretty easy to define a Lambda expression. You need to provide it a name, perhaps a type. If the inference cannot be found, you need to provide the argument list. Again, types might need to be provided if the inference cannot happen. Again, it depends on your scenario. And by default, you'll always need to provide the code body, which says, hey, here's where the code is actually going to go. And again, we'll talk about a few more things in the next coming episodes on learning Kotlin with Lambda expressions.
I want to thank Sentry for sponsoring today's show. Their tagline is, your code is broken, let's fix it together. They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.
Yeah.